And thanks everyone for joining me at Reactive Summit. I've had a great time listening to everyone. The sessions that have gone before me have been pretty inspiring in one way, but also extremely educational. I'm fairly new actually to the Reactive community. As Jeremy said, my name is Rob Hedgpeth, and I work as part of the developer relations team at MariaDB. And essentially what that means is I try to do anything and everything I can to make the experiences of using MariaDB for developers as easy and really as seamless as possible. And one of those areas is with our new connector or our new driver using R2DBC. But that's really all I'll mention, which is my role at MariaDB. What I really want to dive into is R2DBC, the specification itself, and how you can really use it within applications to create a really truly reactive experience. One of the things that has been pretty much a theme throughout this conference so far is being able to create a reactive experience and how important it is to create a reactive experience from top to bottom. And that really includes the database. So that's really what I want to start with. But before I can really talk about reactive programming with databases, or more specifically relational databases, I'm first going to have to start with some of the basics. Now, some of these things have been mentioned before, areas such as reactive streams and the API that goes along with that, and using this thing called backpressure. Now, I don't want to make any assumptions out there that everybody knows what those things are, and there's likely a few of you, if not more than a few of you, that actually do know what that means. But I want to make sure that everybody is really up and running at the same pace, at the same clip, so that when we get into R2DBC and understanding what that is and what it's really built on top of, it'll make a lot more sense from us at that point. And I've got this in here that this is a refresher alert. So for those of you that actually are familiar with this, hold on, we will dive into what R2DBC is. But before we do that, we really need to take a step back. And one of the common themes that I've seen throughout these sessions, which has been encouraging and also helpful from my side, is really taking a look at a very simple example and trying to build off of that to get really a base understanding, or kind of a foundational understanding of what we'd be talking about. And for R2DBC, this is really no different, right? We can take a very simple relationship, right, between a client and a server. Now, it doesn't matter whether you're using a microservice or maybe more of a macro service, or a monolith of some sort. Essentially, the relationship is the same, right? Where a client is going to make a request for something to the server thread. Now, the server thread could be any number of threads, which we'll get into, but think of it now in the context of just one. Now, that server thread could do all kinds of things, but for the purposes of this session, we're more specifically curious about what happens from the database side of things, right? So when you come in from a client, make a request to the server does something that involves the database. And as you can see within this diagram, the client makes the request, a server thread takes that request, and at some point, it's going to query a backend database or a data source of some sort. Now, at that point, there is this process, right, that happens on the server thread where you're just waiting for information to come back. And this is essentially blocked, right? This is this idea of the exact opposite of what we came here for, which is a blocking operation or blocking IO, essentially, which is basically caused by the database at this point. Now, what happens here is, to alleviate this, in years past, what we've done is we've just simply created more threads, right? So, if we have the first request and we're continuing to wait on what would be server thread 1 here for the database to return, well, we can't do anything on that server thread at this point. So we have to continue doing something with our service, or whatever it is on the back end here. And so we simply can spin up more threads. But as has been mentioned as a common theme throughout today, is that dealing with multiple threads and scaling out all of these these threading technologies, no matter what they are, essentially you're still dealing with management of those threads and essentially context switching. And a lot of times that's going to cause memory, consumption, right? Where you have increased memory consumption, and eventually you may even have like decreased throughput. And so this isn't certainly ideal if you want to create extremely efficient or highly efficient applications. And so that really brings us into this idea of thinking more reactively, where we can still utilize that single server thread in this instance, in our particular use case here, and we can request to the database, but instead of waiting on the server thread, we essentially will receive information back at some specified time or some undetermined amount of time from the database sometime in the future. But until that point, we can continue to perform or operate on requests that are sent by the client. And so we can continue to do the same work that we would normally have done on multiple threads on a decreased amount, or in this case, a single thread, which is, of course, by nature, more efficient. But how specifically this is done is really what's important for R2DBC. And as we get into the R2DBC specification, this is why it's extremely important. And it really boils back down to the highest level you can think of reactive programming and the definition for reactive programming, right? As a declarative programming paradigm concerned with data streams and the propagation of change. Now, obviously, we have been dealing with the propagation of change portion of this, but what we're wanting to dive into even a little bit deeper here is this idea of a data stream and why that's important as we go forward in the creation of R2DBC. Well, streaming data, it makes sense, right? I've got here a publisher and a subscriber, but you could just as easily think of it as, A to B, a producer to a consumer. Essentially, something is sending information and something is receiving that information. Now, certainly you'd want to, try to attempt to, the very simplistic or most simplistic case, send all the information, send all of the data at this point. But as has been mentioned, both in the keynote and the session before this, a lot of times what's going to happen is that, if the subscriber in this case is receiving too much information, then they're going to have to backstock or kind of backlog some of these operations because it just can't deal with it. It's overwhelmed at that point. And so in order to solve this problem, we really need to take a look, kind of a deeper dive into what makes up a data stream, or really the anatomy of a data stream, to see what we can take advantage of within that stream of data to help us create a more efficient process. And if we look at a data stream, we can see that, of course, a data stream starts and a data stream ends. But between that, we've essentially got two states here. We're either sending information or we're sending an error. We've encountered some kind of issue while we're attempting to send that information. And all of this happens over the course of time. And these operations are extremely important because with these, whether we're receiving data, whether we're receiving an error, or whether we know that the operation is completed or the stream is completed, we know that we can perform certain operations from a data streaming perspective. And most specifically, as mentioned by Kate and Grace beforehand, and possibly in a couple of sessions, maybe a little bit lighter, is this idea of backpressure. Now, the overall idea of backpressure is pretty simple, right? That you're receiving too much information. So you as the consumer may need to, in this case, this picture, provide some kind of feedback or some indication that the velocity or the amount of information that's coming in needs to slow down, or it needs to be controlled in some way. And so you can think of it as, being able to control that flow, as this diagram indicates, with your hands kind of squeezing that pipe. But more specifically, in our use case, we're looking for non-blocking backpressure, right? In a way that we can, asynchronously be able to use these non-blocking events in order to be able to more efficiently use all of our resources. Well, this is simply done by saying, hey, from the subscriber, let's request a certain amount of information. And the publisher replies in kind, hey, here's a certain amount of information. And onward and forward, essentially, this can be done where the subscriber may say, hey, I want to request one item. The publisher says, okay, I'm going to send one item. I need two now. I'll send two items at this point, and so on and so forth. That brings us to the Reactive Streams API. Now, the Reactive Streams specification was something that was created in 2013 by a couple of small companies you might have heard of, like Pivotal, Netflix, or engineers from those. And essentially, it kind of wrangled all this idea that, yes, we have this idea of a data stream, and yes, we have this way, or this method of using backpressure, or we prefer to use backpressure in order to be able to control the flow. But ultimately, we need kind of a solid specification or even API to really be able to do that. Now, I'm not going to dive into the intricacies essentially of Reactive Streams itself, other than to highlight a couple of areas which are extremely important. I mean, it's all pretty important, but there's a couple of things that we're going to be using specifically in the demonstration that we want to key in on, specifically around backpressure. But as you can see, it should look very similar to what we were doing before, which is essentially we can request through a subscription provided to the subscriber that we want a certain amount of information, and the publisher is going to relay that information. And it can also give you an error or completion status as well. But as an engineer, you're probably wondering, well, what's the meat at this point, right? How do I actually use this, or what's entailed in using this? And as you can imagine, it's extremely light, right? Because this specification, which was added to JDK 9 as well, it is something that is light and allows implementations to be built on it. So the ideal specification. And as you can see, what we saw in the previous image, where you can set up subscriptions, you can create subscribers and publishers, and that entire relationship, which we won't dive too much into the minutia of this, it is all indicated in a series of interfaces. And this is extremely important. So if you take nothing away from the past couple of slides, know that these interfaces in the Reactive Streams API exist, and it's extremely simple and something that we're going to use going forward. But why is this important? As I indicated at the very beginning of this session, we're going to be talking about reactive programming, or reactive event-based programming with relational databases. Now, I key in on relational databases because, as you may know already, a lot of NoSQL, or specifically document-based database systems, already have this idea of eventing. But this is something that's a little foreign to relational databases. This idea of using high efficiency and this event-based approach in order to be able to send information is something that's a little bit more uncommon, even these days, when using a relational database. So we want to change that, and we're going to do that with the R2DBC specification. So we want to be able to create highly efficient applications, and that includes everything from top to bottom. And we fundamentally want these, of course, to be non-blocking, which in this case, we are going to use, obviously, reactive programming mechanisms in the process of using backpressure to use from the subscriber to the publisher to be able to control flow. And this is all really in a response to JDBC limitations, right? JDBC has existed for a really long time, and you can write a ton of really great applications. Tons of great applications have been written with JDBC. Lots of people still prefer to use JDBC, and honestly, there are a lot of use cases where it still makes sense. But in the case of a reactive program within your more holistic reactive system, what happens is that you may create a reactive application or microservice, or something that you have some kind of reactive programming mechanism and event-based approach inside of it. But as soon as you start using JDBC and the JDBC API, by its nature, it is a blocking API. And of course, subsequent or implementing drivers of that API are going to be blocking as well. Now, there are a variety of things that you can do to get around this, including, of course, being able to spin up more threads and do more asynchronous processing, through multi-threaded environments to be able to communicate. But again, that's not as efficient as it could be. Which brings us to R2DBC. So what is R2DBC, right? I've said this and I've intentionally not said the name, but if you're not familiar with it, you probably read it before at some point, probably within the description of this presentation, but it quite simply means reactive relational database connectivity, which you've probably gathered up until this point. But what's important here is that all of the things that essentially we said that we've wanted to do, and even highlighting the JDBC API limitations, are essentially the goals and these design principles from the R2DBC specification and the team designing R2DBC, where it needs to be completely non-blocking. And that is to create a truly reactive experience from the client all the way to the database. It does that by utilizing or using the Reactive Streams API, so that includes their types and the patterns within. But beyond that, R2DBC wants to sidestep or kind of create a different path than what JDBC created by providing a very minimal set of operations, or what we'll see as an SPI, or a service provider interface, which then enables more humane APIs. So this is taken directly from the documentation for R2DBC, but essentially what that means is being able to allow abstractions or libraries to be able to be created so that you can use those more easily with the R2DBC drivers underneath. Now, again, the purpose of the reactive relational database connectivity specification in the driver underneath is that it is supposed to create this idea of completely non-blocking operations all the way to the database, all the way back up, which we know. It does this by first providing this SPI that I mentioned before, so that you can implement, or that vendors can create these drivers or connectors essentially to the underlying data source. Well, why a service provider interface? And I kind of touched on this earlier, but one of the biggest reasons is to circumvent or to deal with failures caused by JDBC, which was this idea that it is both kind of hands-off and hands-on when it comes to APIs, right? In some sense, it needs to be able to have something generic and kind of hands-off so that clients like JPA or JDBI can be able to implement, you know, more inhumane APIs, as well as being able to provide more humane APIs inside of the JDBC API, which becomes kind of a conflict of interest at that point. And for developers or any driver authors, it has been seen as kind of a pain to deal with. And I won't get too much into that. But what the takeaway here is that the SPI is supposed to provide a light user experience, and it deals with things such as special character, kind of question mark binding, URL parsing, which has to be done individually on each driver. So first things first is that URL parsing is done specifically inside of the SPI for R2DBC. And this is nice because then every individual driver isn't left up to, you know, what they have to, you know, go ahead and parse for the URLs, which URLs are pretty standard at this point, so it just makes sense. And this consists of things like the scheme, which essentially says R2DBC. You've got a driver, MySQL, MariaDB, Postgres, protocol, all of the stuff that we'll get into actually in the sample. But know that this URL parsing is done within the SPI. Now, the SPI itself is essentially split into two parts, right? There are things that you need to fully support as an implementing driver, and there's things that you can partially support. Now, I'm not going to dive into all of this, but understand that as a data source underneath, what you really want to do is that you want to, of course, connect to your database, and you want to return results. So what we're going to look at very quickly here is just a couple of example interfaces of being able to set up what is a connection factory. And the connection factory is exactly like it sounds. It's a way to be able to control it specifically for things like state, the connections that a user creates through the driver. So a connection factory is actually exposed to control the creation of connections. And as you can see here, just briefly mentioning, inside of this very simple interface for connection factory in R2DBC, we are using the reactive stream specification specifically for the publisher. So it's returning the create method or it's returning a publisher, right? It's not returning the actual connection itself, it's returning the publisher then you can subscribe to, which makes sense. Beyond that, you look and you see inside of these interfaces very familiar things if you've dealt with databases, which I would imagine almost all of us have, of being able to begin and close and commit transactions, being able to create batch, and being able to execute statements. Statements, of course, are just taking in some kind of string, some kind of SQL. They can be bound or unbound, which we'll dive a little bit into the sample, where you can actually add attributes, of course, into your SQL statements. But again, should look very familiar with how you would expect a connector to work. And then executed statements then will return results, which are essentially just collections of rows. And those rows then allow you to, either using an index or using a column name, just be able to get at the information within your tabular or relational data set underneath everything. Nothing new or exciting here, other than the fact, of course, that it's using the reactive streams specification to create a truly reactive experience. But how can you use it? And that's specifically what we want to get into here. Well, this revolves around the idea of using an R2DBC driver, or you can think of it as a connector to the underlying database. Now, there are a variety of these in different stages of development. Everything from Google Cloud Spanner, H2, Java Database, MySQL, Postgres, SQL Server, and of course, MariaDB, which, where I work, I'm going to just go over a couple examples using it specifically. Now, I say that using MariaDB, but this is pretty common. The things that I'll be doing are almost unanimously done throughout all of the drivers, right? Because remember that there are a certain amount of things that must be fully implemented, and some things that allow you to partially implement, and of course, allowing for vendor differences and some of the caveats underneath, which we won't get into, but know that what we're doing here is pretty much the same with whatever driver you use. So establishing a connection. Well, obviously you're going to need some kind of connection information, and that's pretty similar no matter what you use for relational database. You've got your host, your port number, your username, your password, and it can build these things. Now, ultimately, it builds this into a connection factory provider, but each implementation is allowed, each driver implementation is allowed to a certain amount of leeway to create things like the MariaDB connection configuration object. But know that ultimately it turns into the same information underneath the hood. From there, you're able to use the configuration, or you can use a URL like we mentioned before, but essentially you can use that information to be able to create the connection factory. Now, this connection factory is then used, like I had mentioned before, to create a connection. Now, in this case, I'm using a blocking mechanism off of it so that I am actually waiting for the publisher to go ahead and return my connection object, simply because I can't really do much without the connection object existing, and I don't know how much time that may take. Now, from there, diving into the statement portion of this, this is where we start to see the driver implementation objects from the objects that we saw before inside of the R2DBC specification, namely MariaDB statement. We've got the publisher for MariaDB result, which allows us to return the publisher from select statement.execute. And then we're using some project reactor, which is something that is added as a dependency to the MariaDB driver project, but isn't necessarily something that would have to be used, of course, within any other connector or driver implementation. It's simply a implementation of the Reactive Streams API. Now, all of that said, that is pretty, I would say, that is pretty involved, right? Because if you're like me, you're thinking about all the scaffolding you have to do in order to make that happen, right? Everything from setting up maybe the tiers within your application, being able to reuse certain amounts of information, essentially setting up an entire data access or data tier at that point. But there are better ways of doing this, or rather different ways of doing this, namely using something called an R2DBC client. Now, as I mentioned before, you have the ability to use these clients, which provide more humane APIs. And there's a variety of these out there, but in the sake of time, just gonna skip to the point here, which is that we're gonna look at a sample using the Spring Data R2DBC client. Now, I'm going to go ahead and I'm going to switch over to my example to show exactly how we can use this. But before we get started here, what I want to show you is that I'm going to connect to a MariaDB instance, which is local on my machine, and I want to use a database called To Do. And inside of there, I have a simple table called task, and it just has 3 tasks. Now, of course, this could be a much bigger system at this point, but it's extremely simple. We've got 1 database and 1 table. Now, how do we actually use this? So let's go ahead and open up Visual Studio Code. And I'm going to, for the sake of time, kind of paste things in here rather than just type them out directly. But I'm going to explain them along the way so we can get an idea. Now, rather than using the connector directly, we actually want to use Spring Data R2DBC to go ahead and connect to our underlying databases and handle everything from a connection perspective. But after that, we also want to see how we can control something like backpressure in order to be able to tell the publisher or tell the database connector, the database driver, exactly how much information we want to receive. Now, this all starts really with the dependencies. Now, as you'll see, this is a Maven-based project or Maven build management project, and the packages therein as dependencies are coming from the Maven repository. Now you can see that I've got MariaDB and I've got Spring Data. That's really all we need to know at this point. And again, this is all provided completely on GitHub, and I will send out the links after this or provide the links after this. Now, if we cut over to our applications.properties file, we're going to see, just like if you're experienced using Spring Data, that we want to provide connection details. And here it should look fairly familiar for those slides where we've got R2DBC, MariaDB as our dialect, we've got our domain name, our port number for our database, and the database to do, which I pointed out before, as well as user credentials, which allow us to connect to the database. Now, here I have a fairly simple application just in our R2DBC demo application class, which is where we're going to execute our main method. Now, I've kept this extremely simple so that we can look really just within the console. There's no UI here, but I want to go through a couple of things. First, I want to create a class which is essentially mapped to our table using the repository, and we'll use repository, the repository pattern within Spring Data, but I want to be able to map an object to the underlying table of tasks. And I'm using a couple of things through a package called Lombok, which just allow me to avoid creating getters and setters. From there, I simply want to add the interface. Now I'm going to remove that and just put it as simply as possible. I'm adding a task repository interface, which is then extending inside of the Spring Data R2DBC client. I'm extending the Reactive CRUD repository, which is then mapping to the underlying table. Now, this is essentially all I need to do. Now that I've set up using application.properties, I've set up the connection and I've added the repository. Now I'm ready to connect to the database in a completely non-blocking way. So let's go ahead and do that first by adding in a couple of scaffolding pieces here. I want to auto wire up my repository so that I can use it. And as you can see here, I've made the instance of my application something that I can just call directly. And I'm kind of rigging it up here so that I can stop the main thread and observe the results. Now, I'm going to next paste in a usage of the repository itself and being able to find all of the tasks within the task table. So using the repository, I just want to use the pre-built method provided by the Spring Framework, springframework.data, and the R2DBC data client to allow me just to grab everything within the database. And then I simply want to call that. So I simply just want to say, okay, I want to call my get task methods with inside of this application. But essentially what I'm getting after here is the repository and finding everything with inside of this particular table. And then I simply just want to output the results of my task. So the descriptions or the names. So I'll go ahead and run the application, and I'll see that as we saw before, we have tasks 1, 2, and 3. Nothing fancy there at all, right? This is what we'd expect from anything that can connect to a database. However, if instead, now again, I'm going to paste something larger in here, but I'm going to explain it so that we can get an idea. If instead I wanted to control exactly how much information I, as the subscriber, am receiving, I can use this idea of backpressure. Now, again, we are using the Reactive Streams API in R2DBC. So as you remember before, I have this idea of a publisher, a subscriber, and this in between, or this subscription essentially that sets up a connection. So I can actually just go ahead and add a new subscriber. Now there's a variety of ways that this can be done architecturally, but what I've done is I've created a new subscriber object of type task. And in there, I've actually added or overridden the methods such as onSubscribe, which would look familiar inside of the interface for subscriber, which allows me to take in the subscription from the publisher to allow to create that connection. I'm simply outputting some things like printing out exactly what's happening, and then I'm making my initial request for information. And I'm specifying based on that request, the amount of information or the amount of rows I want to receive back. In this case, I have 2. Then when I receive that information on next, again, going back to the data stream anatomy or the anatomy of those data streams, I have the ability to receive those items. Now, every time I receive an item, I'm going to uptick my count. And I'm just using modular division here to say that every time I receive 2 elements, essentially I want to make a request for 2 more. And then I've overridden the onError and onComplete methods just in case we want to track errors, which hopefully won't happen, but then be able to see when the operation has completed. Now, I'm going to execute this again. And we should see, once this executes, we have exactly what we'd expect, right? We're able to see the onSubscribe, so the actual constructor or onSubscribe method that's delivering that subscription. We have a request for 2 items. We receive those 2 items. And inside of that modular division-based conditional, then we're able to request 2 more. Now, of course, we don't have 2 more within the database, so we receive 1 more. And then the operation is completed. So I know I'm a little bit over, but that is essentially the gist of how to use R2DBC on top of Reactive Streams API to create fully reactive applications with a relational database. As Jeremy mentioned, they made an announcement today that effective today, R2DBC is a part of the Reactive Foundation as a new project, which is awesome. You can learn more about R2DBC at r2dbc.io. And in normal, traditional conference style, I would have been able to give you all shirts specifically for MariaDB. I still want to do that. So if you feel so inclined, please email me at developers@mariadb.com with your address and your shirt size, and I will send you a free MariaDB shirt. And as was mentioned before, I am writing a book on R2DBC, tentatively called R2DBC Revealed, which will be available in early 2021. Thank you very much.